Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the second lecture on the course SwayamPrabha course titled Marine Renewable Energy Systems, Analysis, Design and Development, customized at Department of Maritime Engineering, IIT Gandhinagar and hosted at SwayamPrabha portal at IIT Gandhinagar. In the last lecture, we discussed about the course contents, objectives of the course, reference materials and some of the important aspects of comparing wave energy harness with respect to wind and solar. Taking down the line, we will talk about the primitive development of wave energy devices in the literature and compare and understand their basics for developing such systems in terms of its geometry, site-specific conditions and design parameters. So friends, welcome to lecture 2 where we are talking about WEC development, that is wave energy devices development. In the primitive stages in 1974, Salter developed a primitive device called a Salter's duck. Named after him, which is one of the most popular and first generation wave energy converter design. So, he worked about the geometric development of the design and stated that the WEC design is influenced by wave specific parameters. One can ask me a question, what are the wave specific parameters which will influence the design of any WEC? We already saw that in the previous lecture. Let us quickly recollect them. One could be the wave height, next could be the wave period or wave frequency, wave direction, that is the dominant direction of wave, and of course the water depth, which are site specific. So, wave specific parameters will influence the design. The second could be the hydrodynamic coefficients, which could be radiation damping, reflection, and the rigidity of the system, rigidity or flexibility. If you talk about floating wave energy converter, we address this flexibility. If we talk about wave energy converters fixed to the seabed, then we talk about rigidity. There are many forms. Okay. So, the hydrodynamic coefficients and then the associated coefficients, which we call as capture width ratio. Okay, we will discuss all these in detail with respect to different devices what we are proposing, which has been tested, developed and patented. We will discuss about them in detail. Okay. So, these are the factors which will primarily influence the WEC design by its geometry. So, this was verified by Falco in 2010 and Mai in 2012. So, thanks to the researchers who have given good insight about these contents to understand the listeners and viewers about development principles of wave energy conversion. So, wave energy extraction. So, wave energy extraction depends on, strongly depends on the geometric form of the converter, because the frequency of the motion of the converter has to match with the input frequency of the wave attacking the converter for the maximum efficiency. Next could be the wave direction, and next could be the hydraulic or pneumatic power takeoff systems. Okay. So, based on these, people started developing three essential methods by which wave energy can be extracted. One is, as I said in the previous lecture, one can use something called point absorbers. The other one is called oscillating water column. The third one is overtopping. So, these are essentially, as I said in the beginning, principles of wave energy conversion. These are not devices, they are principles, okay, called as PA, OWC and OT. Okay. Having said this, we have already said that they cannot be generalized, they are site specific, and therefore, many advanced countries like Europe, UK, USA have started developing devices site specific to their interest. So, now let us see what principle of absorption will be used in this. Let us say I have an instant wave attacking the device. Okay, instant wave is attacking the device. So, now I put a device which is point observer, which works only in the vertical direction. So, when I have a point observer working, let us say this is figure A. So, figure A refers to instant wave. Figure B refers to point observer designed to move in the heave direction. I mean, point observer can move in all directions, but predominantly it is tuned, okay, it is tuned to move in the heave direction with respect to the wave frequency, okay. So, heave direction. So, when it moves in the heave direction, it starts radiating waves from the source, okay. So, there is a radiation effect. You can also have a device not heaving but pitching. Even that as well will radiate waves, okay, will radiate waves. But see, there is a frequency difference in this motion. This has a different format of radiation, this has a different format of radiation compared to the original frequency, okay. So, here in C the device is a point observer, but it is harnessed to work on pitch motion. It is tuned in the pitch degree of freedom to work, okay. Now, I have a device which works in multiple degrees of freedom, okay. The radiation will be like this. One can see, friends, there is a similarity of this with respect to this behavior. So, now I can say D is a point observer, but harnessing in more than 1 degree of freedom. So, I can say multi-degree of freedom optimization. Okay. So, this figure is explaining about the wave absorption principle. There is a commonness in all these methods of absorption. Let us say what is the commonness. When I place a device, when the wave is hitting the device, the device is dissipating, radiating waves in all directions. Okay, is radiating waves in all directions. Is an input wave. So now this is what the wave interference pattern. This is what the wave interference pattern, what you see. So friends, when a device receives a wave as an input, the device behaves, responds depending upon its design, and essentially it radiates waves in all directions. Okay, that is what we are concluding from here. After understanding this, one can say the wave energy converter extension, which was started from Salter duct, extended further in different domains as point absorbers, attenuators, and terminators. So, there has been a subclassification of wave energy devices conversions extension into this. Let us see what are the differences between these three very quickly. Point absorber is very small in geometry, in its geometry compared to attenuators and terminators. They are very large. So, that is the first difference we notice. And attenuators are placed parallel to the wave direction and terminators are placed perpendicular to the wave direction, whereas point observers are wave direction insensitive. Friends, this is the major advantage why most of the wave energy converter designs are originated from point observers. So, one can say that if it is a point observer, if it is an attenuator, if it is a terminator, this is the wave direction dominant. So, this is insensitive to the wave direction. If this is an attenuator, this is placed parallel to the wave direction. If it is a terminator, this is placed perpendicular to the wave direction. Okay? These are all extensions of wave energy conversion principle. Remember, the common thing in all these cases is all these devices radiate energy in all directions. Okay? That is what we have seen. Now, wave energy converters are also further classified. Based on operation. The first classification was based on direction of placement, parallel, perpendicular and insensitivity. Now, based on operation, one can say there can be submerged pressure differentials. They work on a principle of operation of submerged pressure differentials, which is actually Cito Beck, designed and developed and explained by Sergienko et al. In 2022. The second can be oscillating water columns. One classical application developed by Sharmila in 2004 is Indian OWC. Then third could be harnessing surge or pitch motion, which is oyster. Oyster is another converter which harnesses surge or pitch motion. The fourth one could be overtopping device such as wave dragon, Tapchan, which are all explained, presented, discussed by Christensen et al. 2005, Diacono and Rusu as 2013. I am giving you all parallel references so that you can learn more about these concepts and the origin of these developments more in detail from the author's perspective. So, we have understand that wave energy has got the maximum potential to harness. Technologies are not advanced developed because they are site specific. And then the question comes, what are the possibilities of developing this onshore and offshore? Okay. What are the possibilities of developing these converters near the shore or well away from the shore, what we call offshore devices? When you talk about this specific question, then point observers are essentially the best choice to develop WEC offshore. You can understand the reason for this because point observers essentially are directional insensitive. One, they are very small compared to attenuators and terminators, and they can harness energy irrespective of wave direction. They are highly versatile and they have hybrid energy conversion systems. Okay. There are hybrid varieties of design available in point observers. Let us say they are fixed type, there can be suitable to shallow waters, then single body WEC, that is only one point observer, there can be multi body WECs, then flexible membrane devices, then pressure differentials. Okay. So, there can be many forms of hybrid designs available on WEC designs, predominantly point observers but there can be of different varieties as you see on the screen. Now, when we start talking about the water depth as one of the important element of wave energy device design, the WEC designs have been started moving, initially limited to shallow waters, initially. The reason was due to economic feasibility and absence of design at deep waters. So, the geometric designs were not available. No geometric design was available for deep waters. Then came into concept floating wave energy converters. Where they can be housed at offshore at different water depths and they behave as a positive buoyant systems. We will talk about the designs later in our lectures, but that is how the generation took place. Now, initially the concept was of harnessing depended on the horizontal water particle velocity of the wave is made to interact with the device, and people thought surge motion will help to harness. Remember friends, for a body along x we call this as surge, along y we call this as sway, and along z we call this as heave. So, initially horizontal water particle velocity is more significant in shallow waters. Therefore, systems in shallow waters mainly dependent on surge harnessing. But they are very limited. As we go deeper in terms of water depth, floating wave energy converters became very popular and unexceptional because of the versatile design and easy maintenance. Okay. So, then when we talk about floating wave energy converter design which are to be done for deep waters, then the foremost issue here, the concern here is stability. Okay. So, in other words, we call this as recentering ability. What do you mean by recentering ability? I have a system subjected to wave action. The system responds. Wave has different direction sensitivity. Now, the system being floating has to be anchored to the seabed for its position restraint. Let us look at the elevation of this. I have a system which is anchored to the seabed using a cable, and this is my water level. Okay. Now, the system will start oscillating in different degrees of freedom. Depending upon the wave action. So, this will have a pendulum action, right. Now, the cables are inextensible. So, the cables will not allow the system to go farther and farther, right. There will be limitation on this. So, what will happen when the system starts moving towards a horizontal direction, the cable will exert an additional tension and try to pull the body back. The horizontal component of this will try to bring back the body to the equilibrium position. This is the equilibrium position. Okay? So, this is what we call as recentering. So, recentering is an ability of the design, not the system, of the design, such that the body attains, or let us say attempt to attain, try to attain its equilibrium position by virtue of design in the presence of forces. I can compare recentering with something called elasticity. You know, elasticity is a material property. Take a rubber band, extend the rubber band and release the force, the rubber band will regain its original shape and size. Okay? So, when you start pulling the rubber band beyond a specific limits of its capacity, it will break, right. So, upon release of forces, elastic members of material will regain its original shape and size when the force is absent. Okay? So, now let us look at the differences. When the force is present, we call recentering. When the force is absent, we call elasticity. Secondly, recentering is a geometric property, whereas elasticity is a material property. Okay? This is essential for any design which is floating, which has got positive buoyancy. This is not necessary for any specific system because it is not system dependent at all, it is material dependent property. So, when you talk about point absorbers or any designs related to deeper water depths, then the system should have recentering ability, which is one of the foremost requirement of this kind of designs. Okay? So, recentering ability is essentially important for floating wave energy converters. So, we can say that recentering is most important requirement of floating wave energy converters. So, if this is achieved, we call this as a stable system. So, as I said in the beginning the previous lecture, stability is one of the important aspect of assessing the performance of wave energy device. So, if the device is designed to have recentering ability, one can say the system has got a stable design. Okay? Having said this, now one can say what are the factors that affects the design. Now, interestingly friends, we already said the frequency of vibration controls the efficiency, is it not? Because the frequency of the system should match with the frequency of the wave to have the maximum efficiency, right. So, frequency is dependent on mass and stiffness of the system? Mass is dependent on the size and material density, and stiffness is dependent on the geometric shape and the boundary conditions. Therefore, friends, one of the important factors that govern the design of wave energy converter is its shape, size, material and geometry. Okay, this was interestingly identified even much early by McCormick in 1979 and further by Falness and Hals in 2012. Okay. So, as the wave energy converter design started developing for offshore applications as a floating system, then people started interestingly investing on multi-body wave energy converters. Multi-body wave energy converters has many advantages. One, the capture width ratio, which we discussed later, is maximized. It can be also designed more effectively to harness energy in all wave directions, and the system can be more stable and can be higher power producer. Okay. But what are the demerits? One of the important demerit is the interference effect of the bodies. Second is the shielding effect of the bodies. When we talk about multi-body wave energy converter design, we pick up these points and explain what would be that. So, are there any examples available in the literature? That is a question which comes to your mind. Yes, there are examples of multi-body wave energy converters. One could be the power buoy, other could be wave bomb. Details of this can be seen at M et al. 2012. We are not discussing about the designs of these existing ones because you can always learn them from the literature. So, therefore, what we understand from here is the presence of multi-body leads to increase in power absorption. More devices now, more bodies now start absorbing power. Okay? So, this will give rise to the net exciting force onto the system. Okay? It invokes various resonance frequencies, not one. Okay? Various resonance frequencies, and therefore, the frequency resonance band is widened. Is widened now. Therefore, it has got a very high possibility of producing more wave energy with higher efficiency. So, details can be also seen in Falness 1999. The multi-body device active in several degrees of freedom gives you more power. Multi-body device active in several degrees of freedom gives you more power, no doubt. No doubt, that is a good thing, okay, which we are looking for. But the difficulties are interactions, what we call coupling motion of different degrees of freedom. It may happen so that one degree of motion can compromise the other. There is no independent freedom available to move because one depends on the other. So, this interaction between the degrees of freedom can also cause some compromising mode of harnessing, and as usual multi-body dynamics will always have more complexity in design. So, each body in such devices requires different proportion of damping. For each degree of freedom. You cannot have an uniform damping, because if you have an uniform damping, then the conversion cannot be maximum. To maximize the conversion of wave energy, you have to have different degrees of freedom, different damping. It means there is a wide damping variation. When there is a wide damping variation, this causes complexity in PTO design, because power takeoff mechanism has to be designed for a specific kind of damping limits. Okay? So, various techniques were adopted in optimizing the shape of the moved structures which can be used for wave energy harvest. Throat shapes, surface piercing cylinders of different cross sections used to harness energy in heave and such degrees were optimized for different site specific conditions. Okay? So, one can look into various literature referred in the website of this specific course to learn more about the devices which have been harnessed and how they can be or they have been tuned for getting the maximum efficiency as multi-body dynamic systems. Okay? So, what we can conclude at this stage that wave energy converter design or wave energy conversion principle has been extended from point observer to other kind of devices, and point observers were considered to be very simple design, but suitable for shallow waters. So, if you want to go for deep waters, so one has to go offshore. When you go offshore, one can go for direction insensitive harnessing, that is an advantage. You can have more power harnessed, this is another advantage. The designs remain floating, but the constraints are you must develop a design with good recentering ability. Once recentering is achieved, the system is considered to be stable in design. So, the whole design now focused on the geometric design of WEC and then specific mechanical design of power takeoff systems, which we will discuss in the coming lectures. So, friends, there are various metrics which govern the design of WEC in multi-body dynamics when you move on to deep waters offshore. So, stay connected with our lecture series on marine renewable energy systems, analysis, design and development, hosted by Maritime Engineering Department at IIT Gandhinagar. Thank you very much. Namaste.